So yeah, so we'll uh, start with I think yeah, we'll do a recap of the course today. I think last time we looked at evaluating LLMs. Um, so let's start with the uh, business use case of LLMs, right? So let's say you work at Amazon and it has a lot of new products coming into the market and from new sellers. Okay, so a lot of new sellers and they have new products. And these are not experienced sellers, so they don't understand the dynamics of how products sell on a marketplace, and they would like some assistance. And so they're not sure how to title the products so they sell best. Like for example, in this image, uh, you know, there's a bunch of
से
keywords.
क्लास था अभी प्रोसेस थोड़ा सा चुतिया हटता है तो
There's a bunch of keywords, and maybe these keywords help, and there's like the title of the product, and then there is like other subtitles and everything included. So is this a good way to do the title? Like the new sellers don't really know because they haven't uh, understood the marketplace well. Or even for existing sellers, maybe they want some understanding from Amazon on what would be a good way to title these products, right? And so maybe Amazon would like to develop a title bot that can automatically suggest titles to sellers so they can generate smarter titles for better sales. Well, let's say this is the use case, and let's say you had to work on this. So there are a couple of questions to think about, and you can share free form or put in the chat or whatever. Is what factors would go into generating good titles for product pages? Like forget about LLMs, just like think about what are like some business factors, like what are some factors you would think about as I think it should have this, I think it should have this, I think it should reference this, I think it should you know include this, uh, that would make for a good title. The second is, um, if you had to use LLMs for this, then would the use case be offline or online inference, right? So just take a maybe 30 seconds to think about this, and then you can share your thoughts. Either you can unmute and share, or you can just put on the chat as well. So that would be, so in this case, like the use of a tool within an LLM might help the LLM score things in a more data-driven way and rank the titles and then generate the titles and then pick the best one and suggest that to you, such as the top two or top three. And so that might be one way to do it, but it's still very fuzzy. Like this could be a full year project, for example, at a company, or at least 6 months project where you actually test it out, try it out, integrate it and everything. So yeah, it would be a complete, like a whole team might be working on this, for example, especially if you want to integrate it into the into production, then it's like a full team's job to make sure this happens. There'll be probably a scientist or two, there'll be like a few engineers, there'll be a product manager, and they'll all be working on making sure that this is getting into production and it's a success. Then you need to also measure that this is actually helping the sellers versus, yeah, sure, you just came up with some titles, I don't know if it's actually helpful. So then you need to get seller feedback, qualitative feedback, quantitative feedback, a way of measuring and benchmarking that's actually helping. And then usage, how many sellers actually get to use this title bot versus you made a tool and then it's just sitting there. Then, then there's also a question of why it's sitting there. Did the UI not surface it properly? Is it only visible to certain people? Do you need to be eligible to use this and all of that? So a lot of factors go into making something like this into a business product, right? That will actually be useful in the business. Okay. Any other thoughts on this, anyone? Okay. Let's look at the next business use case. So this is something we have looked at, which is keyword generation, or we have looked at keyword-based search basically. But this is a reverse problem. So we said, okay, given a keyword, find uh, or we've actually looked at keyword tagging as well, but we knew what the keywords were, like sentiment analysis, like classify this sentence as a particular sentiment. The sentiments are like keywords. But here the question is like, let's say there's a company called Getsy, which would automatically create keywords for products it sells on its webpage. And this would like to in the company would like to create a keyword bot that automatically combs new product listings and tags them with keywords. So now it's not new sellers, it's new products. You have new products and product listings, and then there's description, there is like content, there's images for products, for a given product. There is maybe a few customer reviews, maybe not. So there's a bunch of information, but the question is like, I want to make it more searchable. So this is again connected to search. So not just title, but also keywords for a specific listing might be useful to make the search team improve their search and surface this product for better responses. So maybe they use the keyword bot as a dependency to generate keywords for different titles and then factor that into their search algorithm that will then revamp their search or use this as a feature for their search. So if the keyword bot's job was to generate keywords, how would it do it, right? So let's say the constraint is that Getsy would like to standardize the keywords and limit them to not more than 500, right? So sure, you can say, hey, LLM, can you generate keywords? But imagine that there are millions of products. You can be creating like millions of keywords or hundreds of thousands of keywords if it was just done in a very unstructured way, right? But that's not very useful for search. It's more useful if you can generate like a few hundred or a few thousand keywords and then filter the, let's say in the search, it's recognized that this is a keyword, like maybe fitness is a keyword. Then you filter it down to 1,000 uh, keywords that are related to fitness, and then you filter the search space down to products that match those set of keywords related to fitness. And so instead of looking at millions of products, you're down to looking at maybe tens of thousands of products. So you narrow it down, the search space by keywords, and that might help the search team do a better job at semantic search. Um, but the question is, how do you decide those 1,000 categories of or 1,000 keywords, right? Like if someone gave you a list of keywords, like let's say sentiments, say, hey, categorize this sentence into positive, negative, happy, sad, uh, you know, cheerful, disappointed, etc. You've given me those. I will just have the LLM look at a sentence and say, is it happy? Is it sad? Is it which sentiment is being reflected? And you'll get that. But how do I even come up with this initial list of keywords if I didn't have a starting point, right? So let's take like 20-30 seconds to think about it, and then you can share it in the chat or just call it out. Okay. So yeah, I think we'll need to have some way to generate keywords. So you can still ask the LLM to generate keywords, but maybe you don't have to generate it for every single product. Uh, you might have a broad categorization already in place. You can start from there and then sample a few of the products and listings and then generate some keywords. But then you might get like tens of thousands of keywords from there, and then you can cluster them and then get a smaller set of keywords, right? And then now that you have those keywords, you can say, hey, LLM, can you just run this analysis again and then generate more appropriate specific keywords from the list that you identified? Or you all, yeah. So and you can, so you did it for a, let's say 10,000 products to begin with, and you narrow it down to like a few thousand keywords. Now you can scale that to a million products because now you kind of filter it down to 1,000 through clustering plus LLM's initial search. So LLM initial search plus clustering gave you those 1,000 keywords. Then again, you apply the LLM, and this will have to be run offline, right? And then you'll have to, it might take quite a bit of time. You generate keywords for every single listing based on the keywords supplied, right? So you'll tag them accordingly. So that might be a way that the keyword bot works. And then it's able to retrieve it once you ask, you pass in a product ID, it can retrieve the keywords and then send it back to you. But it's also responsible for maintaining keywords for new products as well, not just retrieval. It's also like updating the keywords, every week or something. So that might be what the keyword bot is doing. So that's another example where it's not just LLMs. So that this is the thing I want you guys to take away, is that LLM is not, as of now, a one-stop solution. It's LLM that augments whatever else that you might already have been doing at the company, and whatever traditional machine learning that has already been happening. Like, you don't want to drive a car with a jet engine. Use the jet engine where it's needed, but if you can just drive a car with a regular engine, then just do that. So wherever LLM is adding value, use it. But if it's overkill, then don't use it. Do something else. So hybrid solutions are like the norm these days, uh, with accessibility and privacy issues and other things that are coming up with LLMs. So use it as needed, and in areas that are not as sensitive, and in places where it's not so expensive. So those are like kind of the key things to keep in mind as you think about using LLMs in a business context. Okay, let's go to the next use case. The next use case is related to reducing costs. So let's say there's another company, Bymart, that would like to build a product assistant that can interact with customers and be helpful and help unblock its customers as they navigate the maze of the offerings. So let's say Bymart is considering using the state-of-the-art LLMs like ChatGPT or Claude, or maybe even an open LLM model like Mixtral. We looked at some of these in the last lecture, and build head agents and sub agents, like just like what we did for the mini project 2, um, with an LLM API in the background, right? As like, okay, there are head agents, sub agents, but there is kind of like a dependency on LLM API. But very quickly, the scientists at Bymart realized that they get millions of buyers that show up on the page every single day. So if you're going to be a shopping assistant, then you don't want to discriminate. So you're going to assist all of the million buyers, which would mean at least a million API calls if you were to just call the LLM for every single question, right? So there's a million buyers like that showed up at different times during the day. There's a million API calls. uh, you can get take a guess on what would be the cost per day, and what would be the cost per year, right? And that could run into millions, as well. So maybe, if not millions, it'll run into hundreds of thousands of dollars every year. And if you have tens of millions or hundreds of millions of buyers, then that will definitely run into millions of dollars in just API calls that were done in a naive way, right? So this is kind of infeasible from a costing perspective. So say by let's say Bymart is looking for a cost-effective solution, and they're looking to you. They're like, I hired you, and I know you want to use LLM, but sorry, it's not feasible. So can you come up with something else? And can you come up with a way that's cost-effective? How would you go about doing that? Building this assistant that doesn't require shelling millions of dollars every year for the company. Just take like a minute to think about this, and you can share your thoughts in the chat. Solutions here. Distill a large LLM into smaller model and host your own. Yep. If you can do your own model, uh, and use LLM as minimally as needed. For example, certain questions have a standard response, like, uh, you know, is it's out of stock? When is it going to be available? I don't need an LLM to do that. Maybe you already code that information that it's going to be available in like a few days somewhere for every product if it's out of stock. You just go look it up and then generate the response. And that's just a database call. So you don't need to use an LLM for it. So simple questions, simple asks from buyers, don't use an LLM. That's going to be expensive, right? So that's definitely one. Distilling a larger LLM model to simpler one also helps, because you can understand, like, intent detection can be done using a smaller LLM. What's the intent of the query being asked? Like, what we did with the mini project 2, is it a relevant question? That's an intent. Is it a relevant intent? Obnoxious intent, um, irrelevant intent, greeting intent. So there are intent classifiers that can be built based on BERT that just do this job, right? And they'll do a reasonable job. They may not be super accurate, but they'll get the job done for the most part. There might be some inaccuracies, so you can still rely on it. And then so that's something that you can. So breaking down the steps of this assistant into a design, and it could have head agents and sub agents and everything, but not having every sub agent be a LLM API call. That will be the key thing. And also, yeah, so you'll have to have alternatives then. If it's not an LLM API call, what is it going to be? It could be a bird call, and bird call is something that you host, and so you incur much less expense to do that. So, or you can do a lookup. It's a frequently asked question. Is it a frequently asked question? Okay. Is it the same question that was asked like 2 days back? Okay, it is. So then I know the response. So let me share that. So being able to do a fuzzy match with questions that were asked in the past is another way to kind of do this, right? So uh, are there solutions for running open source LLMs? So, open source LLMs also have this other issue that, like, for example, some of the open LLMs are under research license. Like, if you look at Microsoft LLM, it's a research license. I think Llama, some of the variations also have a research license. And so you cannot use it for business use cases. The ones that you can use for business use cases are expensive. The ones that are open have these kind of research license kind of a drawback. So you're kind of in a catch-22 situation sometimes. Um, yeah, I think subagents, I think the other point, yeah, use subagents that can do simpler tasks and only use LLM call when it gets really complicated or if it's needed. And you can even have like head agents and subagents that never call an LLM for a particular buyer just because all the questions got answered with simpler models. So that again saves you, if you can increase that percentage and reduce the use of LLM to the most like complex question that was being asked, or then that's another way. Or use an LLM to distill. So with distillation, you still use LLMs, but offline, not online, not at inference time. So you did the job beforehand. Now, when you're serving the buyers or customers, you're not actually doing LLM API calls. You're actually using the knowledge base that you built. For example, we did the keyword extraction in the previous slide, or we did, titles, so yeah, keyword extraction is a good example. So you did that offline. Now you can use the keywords online because you've already done the job with the LLM. So offline uses of LLMs plus online simpler models is another way to use LLMs and the performance of LLMs, but not online where you incur a lot of cost, right? So this offline online kind of a breakdown can also help save costs in a production environment, right? Like I was actually surprised with the mini project that people didn't think of like non-LLM solutions for subagents, because that's the whole idea. Is if everything is an LLM, then it's super expensive. Uh, so many API calls and so many timeouts and so much of throttling that's happening and so much of cost. You already saw what's the flip side of using LLM for every single, subagent. So yeah, it's a combination of existing software that is not non-LLM plus LLM as needed. So I think that's the way to go at this point, where it's definitely not cheap to get high performance LLM API calls done. Okay, so this was yeah. I think the second one is also on the same along the same lines where uh, there are multiple API calls, right? So we spoke about this. And so instead of like doing one API call, let's say you're doing three API calls, the very naive solution, oh, I have this fancy sub agent and this agent, that agent, everyone's doing an API call. Instead of doing one, you're doing three, you're shelling three times the amount of money. Especially if the token size is kind of similar between the API calls, then you're actually spending 3x where you could have just been, so cut it down by three. So these are like very important decisions to be made when you actually are working with LLMs in a business context because of scale. So whatever decision you make is now going to scale out to millions of users and millions of products. So when you're in that context, like every single cost cutting measure becomes very significant. You're cutting cost while not trading off performance. Like keep the performance going in some way, but don't cut, like don't be too expensive for the company, right? So that's like a definite consideration. Like for example, here I search for, um, I did a I did a full sentence search, right? This was on Walmart, and it gave me this as results, right? So probably if you did keyword search, like sleep aid for beds or something or whatever, a mattress add-on or whatever. It would just give you that. But it did not surface uh, anything that was non-medicinal as a response, right? So like when you want to I mean, search is like a very, very, very difficult one in any case. Like, but using LLMs, you can probably like look at this query and detect keywords. Like maybe one of the keywords would be bed, and then you would actually look for mattress toppings or something that will help with better sleep, as in addition to sleep aids like these that are being shared. So you'll get a diverse set of results. So again, this is an example where keyword bot would play a role in parsing this very quickly, uh, generating a keyword, and using the keyword to retrieve results as well. But anyway, search is like a very difficult one. So doing all of this might incur more latency. So that's another constraint, because I can do a lot of things, uh, but search especially is like very limited in terms of latency, and that limits the amount of AI you can actually use in search. So it becomes very expensive to have a lot of things going on to retrieve results. Okay, so based on the previous examples, right, we can put in a few design considerations, especially uh, with respect to LLMs, right? For LLM uses in business context. So one is cost effectiveness. So if you're a scientist or engineer working at a company that is trying to productionize LLMs and serve, let's say, millions of customers or scale to millions of products or whatever, or millions of messages that you're parsing, then the question that will be asked to you is, if we went ahead and deployed with a scale that we are operating at, would it be $100,000 more? Would it be $1 million more? Would it be tens of millions of dollars more to use your AI solution? And you need to be able to come up with an estimate and break down, and and then and you say, oh, I think it'll just be tens of millions of dollars, and it'll be like, sorry, no budget. So cost effectiveness is a very important consideration in a business context. Is like, you can propose a very fancy design solution with all sub agents and agents, and it might just be strike down because of the cost. So it becomes a very important factor, and it helps you optimize as well. So then latency is another consideration. Do we need a real-time response, or can the solution take some time? Like for instance, if you're working with experience where a user comes online, and after like a few seconds, there's a notification from a bot that says, hey, how are you doing? How can I help you? Doesn't have to be immediate, right? They just came onto a shopping website, and then the bot came in after a few seconds, or it responds in a few seconds. The user might be okay with it. So the point is, it's not going to be sub 100 millisecond latency in that case. You kind of expect the assistant to take some time. You're like, okay, you're thinking, you're coming up with a solution, and you can have like a scrolling thing that say, or a kind of a circle that says, I'm thinking, AI is thinking, and then you're fine with that. In other cases, you want instant response. Like you go to Google search, you cannot say Google search is thinking as it retrieving results. Oh, sorry, that's not going to work for me. Because we're used to instant results with Google search. So that's another question to ask: is what's the latency? Is it real time? Solution can take time, or is it an offline thing? You want to do offline LLM solution, or is it like, so? Those are questions. Like, is it a notification? Like you go ahead and ask your query, I'll get back to you in my own time. I'll give you a notification. That's a different from like a real-time response. The notification can happen in a minute as well. So then you get a minute to actually do all of this and get back all of the AI processing. So the user experience is kind of related to the latency in this context, right? What's the kind of user experience that we want to have with the AI that we are building for the business problem? uh, Performance, like what performance metrics, offline, precision recall, online, click-through rate, or GMV, revenue, other things. And how are we tracking it, A/B tests or offline tests? And does the AI design meet our needs? So does the use of LLM in my business use case meet the performance metrics that I care about? So this is something that if you're a scientist, you would anyway invest time on. This is kind of bread and butter, right? You would spend time getting evaluation metrics. You won't just say, hey, here's a design. I think just let's just go implement it. You're going to actually test it out. You're going to benchmark it. You're going to evaluate it. If we looked at LLM leaderboards, you might want to develop like benchmarking data sets for the specific business context, because LLM leaderboards are not looking at product use cases specifically. They're looking at general coding, general math, general reasoning, general Q&A, multiple choice questions. Are you doing a good job on that? On like anything like weather, very, very, very generic topics, not related to products. But when you come to this product specific, problem that you're solving, you need a product specific benchmark, and that becomes very important. It's not enough to know that your LLM has done a good job on general question answering. Because now the focus is on products. So because it's product question answering, you want to specifically benchmark for product use cases, then you need to develop product benchmarks, and that may or may not be available, and you need to build it out, and then you need to evaluate, and that's going to be part of the job. So performance monitoring, specifically accuracy and things like that. So call like for example with mini project 3, we looked at calculator tool. We didn't just build a calculator tool and we said here's a tool. We actually benchmarked it, right? We tested it out. We saw that if you didn't use the tool and if you use the tool, you have a 20% bump in accuracy. That's pretty significant, and that's how you will showcase in your company with the business problem you're working on, that hey, it's not just that I came with a solution. I've benchmarked it on some real data that shows me that this is a good thing to do. Let's now go test it out, maybe do online testing, and then we'll deploy it, right? The fourth dimension, which has now become very important, like for example, Microsoft invests a lot in responsible AI. There are other companies that are starting to invest in responsible AI, is uh, to review LLM solutions as they're being developed in-house to ensure that they don't adhere to safety protocols. Otherwise, you'll have like a change of ethnicity when you ask a query, the image being generated has a different ethnicity or different race or different background, and that can put off people because you didn't do proper checks, and you didn't do good testing, and you didn't check for safety and all of this. You didn't check for sensitivity of the responses. So responsible AI is another area. So you might have a team at a company that's actually saying, okay, you want to deploy LLM solution, send it, put in a ticket. We'll come and review your solution. We'll ask you questions. We'll be satisfied. We will see if you're satisfied. If you're satisfied, we'll let you go ahead. Otherwise, we'll ask you to come back with more data that proves to us that your solution is actually. So the burden of proof is on you to show that it's actually safe and responsible and it's going to behave in a good manner, especially if it's a shopping assistant. Like you have a shopping assistant that depends on LLM, you want it to be really safe. Like we saw, you can do prompt injection attacks and it can start behaving adversarially, right? So that's another dimension that companies are investing in as they develop LLM solutions. So that might be a separate team that you'll have to go through for review process before getting a green signal, and then you go ahead and push that as a solution for your business need. Any other considerations you can put in the chat or call it out? Okay, cool. So let's talk a little bit about responsible AI, right? I mean, there are different dimensions to responsible AI. Uh, for example, is it interpretable or unexplainable, right? This is important for like a medical use case. Very, very important for medical use case. Probably important for other places, but wherever there is sensitivity to the use of AI and what AI is saying, you want to be able to explain why is it saying what it's saying. What reference, like at the minimum, if you're using LLM, it should quote a source of truth in these contexts. Like don't just say this is the answer. Like for example, in the mini project 2, you generate a response from the RAG model on the book, code the page from which it's been taken so I can go and manually verify that it's actually right myself. So that would be interpretable and explainable AI. So you're actually explaining why the LLM or your AI came up with a solution. and not just me take you, believe you for that, right? So I want to probably independently verify it as well. So that's interpretability and explainability of AI. Explainable is easy because like we have chain of thought. That's one way to explain LLMs, right? Referencing good references that are available. That's another way to explain. Uh, Interpretable, yeah, it's also interpretable, but if you want to say, yeah, nowadays, I mean, previously it used to be that interpretable AI and explainable AI is also about how the model actually came to the result. Now it's too much to ask to say how did the LLM come up with this result. So we just take it for a fact that okay, you did your thing and you came up with the result. We're not asking LLM. But previously it used to be that with deep learning models, you would say, why did it come up with this result? Then you go and look in some layers and stuff. So we don't do that anymore with LLMs at this point because it's too huge of a model to go and dig into the LLM architecture and understand how it came up with the solution. Um, yeah, so private, like keeping data private, data privacy is like also part of responsible AI. Robustness refers to like prompt injection attacks and other things that you're not impacted by any of these attacks, that your model is robust uh, and resilient. So that's something we'll also looked at. um, what else? uh, yeah, I think complying to any laws. I think there are laws that have started to come up in different, like European Union passed in a law on the use of AI. So if there are any laws and regulations in the area that you want to comply to, so that's also probably part of responsible AI. Like also simple things like you want to deploy something that's not meant for production use case, but only for research use case. That, like, for example, Mixtral is not, or Phi, the Model 5 from Microsoft, you cannot use it for production use case. So then that'd be the job of the team as well. So that's all of those things come under responsible AI. Okay. The other thing that's very interesting these days, like if you saw, how many of us saw there's a news on the advent of Devin by Cognition AI. It's like a few days back, news from a couple of days back, that says that Devin came up with an artificial software engineer, right? So AI software engineer, so that can do the role or job of a software engineer, is bringing up serious threats for software engineers who are questioning their existence because now Devin is purportedly doing the job of a software engineer, right? So these are like ethical or moral questions or like that come up for scientists and engineers in the LLM era. It's like, what is my role now that LLM is doing a lot of what I'm supposed to be doing at a company as a software engineer or as a scientist, right? So this is like, uh, uh, taken from the charter of Devin. So it says the human user simply, or what Devin actually does. So human user simply types a natural language prompt into the Devin's chatbot, and the AI software engineer, which is what it's purported to be, takes it from there. So developing a detailed step-by-step plan. Usually software engineers come up with a plan or design for how they want to develop a system. So it comes up with that plan, then it uses that plan to begin the project using developer tools. Okay, where are the developer tools? What are the developer tools? Maybe there's like terminal, maybe there's other developer tools, maybe there's Git, and whatever other tools that it needs to use. It starts using those tools just like a human would, and then it starts writing code. And the funny thing is, you can see all of it in action as if there was a real human sitting behind some machine that you've kind of done a remote desktop into, and you're viewing what they're doing. But it's actually the code doing all of it, but showing you how it's doing it, showing you as it's doing it. So it feels like a human is actually doing it. So you can actually view all of the operations. Like you suddenly see something is getting clicked, a browser is being opened. It's not that your system got hacked, but it's just that the AI is actually performing the task and opening things like a human would, so you can actually see what it's doing, um, and writing code, fixing issues, testing. So I think it's a if it is what it is, I don't think it's open to testing as of now. It's just in the news. But if it is what it is supposed to do, it's a big milestone and raises serious questions for software engineers specifically on how their role will get impacted. But here's my question to you: like, if things like this come up, how do you redefine the role of a software engineer in this? With, for example, with the advent of Devin, um, feel free to share your thoughts. Yeah, if 13% of GitHub issues were solved, that's good. So it speeds up the issues that are being solved. But there'll always be complex queries for which even a software engineer doesn't know what the solution is, and they'll have to iterate and dig up and figure things out, or come with innovative hacks. So the use of human intelligence to solve software engineering tasks, that doesn't go away, and there'll be more and more complex tasks that always come in. But done and dusted tasks that are easy to solve, maybe those can be relegated to something like Devin. So you'll still have a human software engineer operate an AI software engineer to do the simple tasks and resolve simple issues, or get it to some status and then you're like, okay, thank you for doing what you do. Now let me take it over from here, kind of a scenario. So you'll still have that. It'll just boost up productivity. It'll just mean you can get more work done, right? And then you can take on more projects, which will mean you'll need more people anyway. So this, it'll just, the productivity will probably go up. But then if productivity goes up, then a company thinks maybe I'll need to hire more people so that I can manage more of these AI software engineers, so that I can get more work done. So your role will now turn into a manager for an AI engineer, uh, while you being a human engineer as well, right? So it's the same thing. Like, what were people doing before software engineering? What were people doing before you could actually code things and automate things? You were doing it manually. Now that you have coding, you still have work to do. You actually have more work to do. So it's the same thing. Um, yeah, you can say it eliminates certain tasks, but it also helps you do more things as an engineer. So uh, that's how you kind of adapt and you change your role. Like we have GitHub Copilot, for example. Before Devin, there was Copilot. And what does Copilot do? It helps you write code faster, but it's not replacing your job of writing code. It's helping you write faster. Devin is taking it to the next step, but still there's like the idea of managing Devin, right? So um, yeah, exactly. So engineers will have to adapt. That's the bottom line, uh, and focus more on complex design and thinking more about the problem solving aspects that would be still hard for LLMs, and versus like, or break down a big piece of project into smaller projects and give those smaller ones to Devin. But you're managing the bigger one and you're still working on some piece of the code. So that might be another way to think about it. They'll have to bring in a SWE to fix the code. Yeah, exactly. Yeah. So Devin is not going to own and, be on call if something went wrong, right? So the human software engineer will manage the AI software engineer, and yeah, exactly. Uh, so yeah, it does bring in some insecurity, serious insecurity. Like like until now it was okay because you're still augmenting a software engineer. But once you say, hey, this is a virtual software engineer, that shakes people up. And so, but you still have to adapt and move on, right? So this is like a really recent development. But Cognition AI has been around for some time. They were in a stealth mode. Uh, I interviewed with them as well a couple of years back. So they were in stealth mode for quite some time, and no one knew what they're developing. This is what they were doing, and I think some of them, the founder, I think they were related to the IBM Watson that was developed way back. So they wanted to develop something like that, and I didn't know what that was. It's turned out it is this. Okay, so and then you can ask the same question for a scientist, right? Like we have NLP scientists as a specific role these days, NLP scientist, NLP engineer that specialize in natural language processing, but LLMs doing a lot of the job. Again, you wonder what's the role of NLP scientists, but we covered that, right? With the use of science has still a little bit of more of a leeway, you can say, because there's cost issues and privacy and all the other things. So you're now managing an LLM just like a a software engineer would be managing an AI engineer, you would be managing an LLM. So that's like the equivalent. You kind of deciding when to use the LLM, when not to use it, and stuff like that. So you just have to adapt your role. The roles are adapting. Doesn't mean you're going to run out of jobs. Just need to be more adaptive and incorporate this as part of your skill set. So now you need to kind of be good at using Devin, basically, in addition to being good at general coding. So that might be how roles change in the LLM era, right? Okay, cool. So that's a fun thing to think about. So yeah, I think that's those are some things I want to talk about, like especially touch upon some of the production use cases. So we did that today. I'll just do a quick recap of some of the things we covered in the course so far. We started off with deep learning fundamentals. We covered a lot on deep learning, and we spoke about how adding nonlinearity and then more layers, uh, so number of layers plus nonlinearity was kind of the key insight to modeling more and more complex tasks and doing more and more complex tasks. Think about LLM. LLM has like tons of layers of nonlinearity and tons of layers as well. So that's how it's able to do what it does, and it's able to, yeah, it's a whole, it's basically a whole gigantic neural network, deep neural network. And if you think about yourself and myself, our brain is basically a complex billion neuron neural network where constant firing is happening every single second. So we can process and understand, like even as I'm speaking, you're processing and understanding what I'm doing. A lot of neurons are getting fired in your brain. So it's like a neural network that's running for life to understand and grasp what's happening in the world, right? And so you can imagine that the basis of intelligence, especially in the context of understanding the real world, material world, was already present with our own human brain. We're just bringing that more and more into the AI by mimicking it, right? And so now we've hit the scaling, the architecture, the size, the depth that can, and the data that can actually match uh, some of the human performance. So we've just got into that threshold in our history of human race, that we're able to come to this point. So we said that number of layers and nonlinearity, that's the key principle. Like, and I just kind of scale it out, and we have reached LLM era right now. But previously it was like traditional machine learning, okay, don't touch neural networks, not feasible. Then we said, oh, deep learning, that's the new kid on the block, and it's doing amazing things in computer vision and natural language processing. And now the new kid on the block is LLM, which is like, hey, deep learning, don't worry about it, don't stress. I got this down, and I can do much more than what you can. And then now we have Devin, which is like kind of going ahead, really, really pushing the threshold. And there might be a point where you have like one of the Tesla robots getting integrated with one of the Devin, and so you have the hardware matching up with the software to make a humanoid that can actually be very intelligent and perceive and learn and understand and speak like humans do, but looking like, seems like it's not too far away. But again, it's not like in the movies where uh, you know there is some malicious intent for a given humanoid, but it could be that the humanoid, there could be attacks on the humanoid that can make it rogue for whatever reason, like we saw. But I think that's something that's definitely a concern for AI, right? Is if AI systems went rogue in a way that is destructive for us, we need to have checks and balances on it ahead of time. So that's like ethics and responsible AI and robustness of AI and robustness of AI to attacks. Uh, Even like if you have a Tesla car and it's running, I mean, there's autopilot, but let's say it got hacked, and then the car is being driven remotely, and then that's a cause for concern. So even something simple as a Tesla car is an issue, and something as humanoids coming into the market at some point that are full-fledged and have both the physical capabilities as well as the intelligence capabilities integrated, then the idea of attacking and making it rogue becomes a more of a difficult proposition to handle. I think that's something I'm sure that people will be putting it in place as things come out more and more, become more and more advanced. Um, anyway, sometimes science fiction meets reality, especially in our era. It's kind of coming up, right? The movies that we used to see in 1990s are now coming up as a reality today, right? So anyway, so we started with deep learning fundamentals, and then we said, let's look at embeddings because it's a very, very practical tool to do search and smart search and semantic search. So, you move from naive search to smart search or semantic search. You need embeddings. So we spoke about the use of embeddings for that. And as a way to um, uh, understand products, understand objects, understand anything, search and retrieve. You want to retrieve pages from a document. We use a RAG, and then the RAG uses an embedding inside a pine cone, and it does cosine similarity. So the idea of an embedding is very, very powerful. So we spoke about how embeddings get generated. We spoke about word to vec. We spoke about glove embeddings. We said it's bilinear. It doesn't have the a non-linearity as let's say an autoencoder embedding does. And then we spoke about autoencoder embeddings, and then we spoke about transformer embeddings, and we also have OpenAI and other LLM embeddings as well these days that can be used. So that are kind of state of that. We also spoke about BERT embeddings, and we said BERT BERT model is pretty sophisticated. Like BERT gets used a lot in industry these days as an alternative to LLMs, and distilling the BERT for specific use cases is like a constant scientist job in the NLP space. Is use an LLM, get some data, use it to annotate a BERT model, fine tune, and then use that fine tuned BERT model to solve simple tasks. So BERT is pretty powerful, but we also saw that BERT embeddings uh, are not as good for cosine similarity. And then so then we came up with sentence BERT, right? And we said sentence BERT, S BERT does a much better job for sentences. And we saw this in one of the assignments. We worked with sentence BERT as well. And we also looked into some of the architectural side of BERT, the training side of BERT. How is it pre-trained? Uh, it uses a mass language model, uses next sentence prediction. Is it supervised, unsupervised? We said it's self-supervised, right? Self-supervised learning. So this is very cool because you don't have to look for data. Whatever data you have, you just kind of parse it into input and output, and in a self-supervised manner, you learn and pre-train the BERT. Um, and then you can just use English Wikipedia and book corpus documents. Like this was the start of self-supervised learning in a very scalable way, and LLMs are doing that in a much, much bigger scale. So just kind of they took off from where BERT left off, and then they kind of took it to the next level, right? So we also spoke about BERT as encoding transformers and GPT as decoding transformers. So we made that distinction between encoding and decoding transformers. But encoding are good for classification, discrimination, intent detection tasks, whereas the GPTs are good for generative tasks. But it turned out, even though it was good for generative tasks, as GPTs went from GPT-2 to GPT-3 to GPT 3.5, suddenly even the generative model was very good at the discriminative tasks. So you didn't have to go back to BERT to do classification. You could still use LLMs. That's how LLMs are doing both generation, the generative aspect, but also doing discrimination and reasoning and other things. So suddenly the decoding transformer was sufficient to do both the job of the encoding transformer and also the decoding transformer. So that's where the reliance on GPT became even more after GPT-3 and 3.5 came out from OpenAI. And that started the LLM revolution, because now you just have to go to one place to and fine tune it and pre-train it in a really good way, and it would do well on many of the tasks. Um, then we looked at two-tower architecture as well. We spent some time on two-tower architectures and looked at different use cases, and like sentence similarity, movie user similarity, product similarity, and we looked at one use case with Instacart recommendations where the two towers are query and product, and so you can change the towers to represent different things for different business use cases, and you can come with all kinds of towers. You can have a customer product tower, query customer tower, all kinds of combinations you can come up with, and you can again pre-train or train the model and then fine-tune the model, or you can have a pre-trained model that you can fine-tune. So we spoke about that as well. And these generate embeddings that you can use for cosine similarity as well. We looked at some of the architecture design of Instacart and the use of embeddings here. And related to this, we also spoke about data augmentation as a very important use case in natural language processing for businesses, for expanding product signals, expanding cold start data, um, and also, the use of LLMs for data augmentation. We said that LLM has many you can use LLM in many ways as an API, direct API call for data augmentation, right? That's a very big use cases, right? You can use LLM for that. For verification, you can use LLM as well. So there are different use cases, and data augmentation is a very important use case for LLMs. And we spoke about like Phi as a Microsoft LLM model, which is a small language model that was trained completely on high quality textbook data, which is generated from a large language model. So we spoke about how this is like LLM distillation, right? So where you go from a large LLM to a small LLM, that's an LLM distillation. So we spoke about data augmentation and how important it is. And we spoke about LLM as an annotator by itself. Like LLM can be an annotator, um, and you can use it as gold standard if you can trust it. And it can help you with um, annotating data in addition to human annotators. So human annotation is the best in most cases, but if you don't have access to humans to do that, or it's expensive or it's time consuming, then you can also do a simpler stopgap approach of using LLMs in the meantime, right? Then we did I think we covered a bunch of notebooks as well. A few of the lectures are completely on notebooks, and we did automated prompt engineering there, and we did a few other things. Um, we also looked at tool former, and this was pretty important topic that we covered in the course. In the use of not relying on LLMs for reasoning when it could just rely on a tool. Very simple. Why do you want LLM to do extra work when it's not designed to do that? It's not designed to do math. Use a calculator. It's not designed to reason complex things. It's designed to generate. It's designed to be a salesman. You know, like, yeah, I can talk flowery language. I can play any role. I can do simple retrieval and package things and generate answers from documents. I'm very good at that. So don't ask me to do reasoning and math as much. So this is where the idea of tool former and using tools, different tools in an automated way comes into play. So and the key innovation of tool former was that the LLM generates a prompt that then that includes the use of tools, which it will execute only after it has fetched the results from the tool, and then it uses that information to then process and respond. So and then we saw the use of tool former without fine tuning. We used it in the calculator, uh, you know, problem in the mini project 3. So we looked at that as well. Then we spoke about denoising autoencoders. We spent a couple of lectures on this, 2 or 3 lectures, to understand autoencoders, how they're very good at embeddings, how cosine similarity based on autoencoders is better than PCA or other methods. Then we looked at use cases for images, and we said it's a very good way to compress images. And we said to make it more robust, we would actually introduce noise in images and then try to predict it without the noise. And we also spoke about how this idea of starting with a noisy image and generating a denoised image is like the key foundational principle behind stable diffusion, where it does this in a repeated fashion. And we spoke about stable diffusion as having two autoencoders embedded in it. One is the outer autoencoder and inner autoencoder. And we said how it was like a very creative use of denoising autoencoders to get the job done in a very, like, I mean, stable diffusion is not perfect, but even the idea that you can generate a high quality image from just text is crazy. Like, this is something that you wouldn't believe, like, even a decade back, has now become a reality because there was a creative use of denoising autoencoders within the stable diffusion architecture. And we saw the architecture for stable diffusion. This is the outer uh, like we had an outer autoencoder, outer autoencoder, and then we have the inner autoencoder. And we spoke about how the outer and inner are trained separately, but they're put together, and then together they do a good job of starting from an input and then going all the way to the image, the text input, all the way going to the text image. And we spoke about how the training is done from the image, the pixel space, back to the pixel space, whereas the inference is done from the text to the pixel space. We spoke about all of those details, and we spent a few lectures, 2 or 3 lectures on this as well. And then we spoke about adversarial attacks on LLMs, and we said how easy it is to inject random characters and phrases inside an LLM prompt that can mess with the behavior of LLM. Then now it starts to behave adversarially, where it's not supposed to do that, right? And so there are certain phrases and certain characters, special characters that trigger an LLM to become a little bit rogue. And we saw that's like prompt. We also spoke about prompt injection attacks, that you don't have to necessarily pass this into a prompt, because that would be suffix injection, but you can also have a web page that has says something that the LLM thinks of it as an instruction, and then it visits that web page, but it sees that text and says, oh, maybe I should add this to my prompt, and it starts behaving differently. And then so there's prompt injection attacks, there's also suffix injection attacks. We spoke about different kinds of attacks that can happen on LLMs, and we saw live examples. Like we changed the behavior of GPT 3.5 as it stands today to behave adversarially with bad prompting. uh, and more recently, to like today, we spoke about design. We also spoken about design considerations in the past. So we spoke about design considerations for LLMs and businesses, right? So cost effectiveness, latency, performance, responsible AI. These are like the three or four buckets that you have to check off. It's not enough to check off performance. It's not enough to check off latency. It's not enough to check off cost effectiveness. You want to check off all these four when you have the use of LLM in any business use case, in any company these days, because they're not there yet on safety or cost. So you need to check it off. Your business proposal and your AI solution has to have these parameters in design consideration, and they'll probably get reviewed. And then once it's checked off, only then you can actually move forward into a production solution for in the use of LLMs in production. Okay, so thank you so much. It was a pleasure spending the last 2 months with all of you. And I think I learned a lot as well in the process of um, coming up with these lecture materials and the assignments. Everything is from scratch. We don't have any, you know, any other reference, because we didn't have any other lecture or course taught on LLM. So this is the first one. It's a pilot, and so it's great that we could make this happen. And I think we'll probably have more editions of this and take forward the learnings from this course. And thank you so much.